let's go. Okay. Mm. Huh. Oh. Why is it private? Okay, now it should be good. Alright. Okay, let's get into it, everybody. We're gonna be doing some math homework today. Isn't that so invigorating? So yeah, I just have a review to do for the test tomorrow. So, yeah, hope you guys enjoy talking to me. Okay, it should be negative 28k to the third plus 56. Sick. Okay. 4y to the second times 5y to the fifth plus y to the second minus 2. It's 20y to the seventh plus 4y to the fourth minus 8y to the second. Okay. 20y to the seventh plus 4y to the fourth minus 8y squared. Sick. 11x minus 4y minus 4x. That'd be 88x. Negative 32y minus 32x. So it would be 56x minus 32y. How? Am I stupid? Oh, that's a Z. My bad. What? Huh? gay? Oh. Okay, yeah, I'm just stupid. Negative 3, 9x plus 6y minus 12z. Negative 27x minus 18y plus 36z. No? What could be wrong? That's some garbo right there. What could be wrong? What? What? That's not what I said. Actually. Okay, this better work this time. That's 14x minus 24y minus 20z. Cool. Negative 3x plus 4 by 5x minus 5. Negative 15x 20x 15x and negative 20. So that's negative 15x squared. Negative 15x squared plus 35x plus, no, minus 20. Sick. $2k plus 1, 2k minus 1. Oh, that's just 2k squared minus 1 squared. So 4k squared plus 1. Okay, it's minus 1. I guess I'm just stupid. Luckily it gives me a second chance. Okay. Negative 4c plus 1, and then negative c minus 3. So that's 4c squared. Negative c is 12c. Negative 3. So that's 4c squared plus 11c minus 3. 4c squared plus 11c minus 3. Awesome. Okay. Write the expression in simplest radical form. I'm gonna do the radicals last. Find the product and simplify. I can do that. B7, negative 9B5. That would be negative 9B to the 12th. Negative 9B12. Sick. Okay. That would be 60A to the 6th. Mental math for the win. Negative 3 to the Y to the 6th times Z to the 7th. Awesome, gotta love it. That's just A. Sick. Oh, it's so hard to see. That's better. The stupid background to make it so you can't, like, use a program to solve it is so annoying. I'm gonna go to the next. Okay. That's N to the 14th. That's negative 2 K to the 33rd. Huh? Oh. Negative 8. Okay, so negative 8C to the 12th by M to the 42nd. Awesome. The degree? 9. Number of terms? 3. Type of polynomial? That's linear. Write the polynomial in the form AX awesome. Okay. Simplest radical form is gonna suck. Okay. Um, okay. Apparently Minecraft Champions Island came out. Yo, Dakota, what's up? I'm trying to simplify some polynomials, and I hate it. I mean, simplify radical expressions. So 98 and 10. I can divide them both by 2. Over 5 times 5. Wait, no. Oh, wait. I gotta get my Desmos scientific calculator up here. 49. Okay. Seven times 7 over 5. So also 7 squared over 5. So it's also 7 over square root of 5. Let's try that. 7 over the square root of 5. Yes! Yes! Oh my goodness. I hate radical expressions so much. Oh, that's just divided by, that's 1 over 9. Easy. It's not. Never mind. I'm stupid. It's not as easy as that. Square root of 1 over 9 also is the square root of 1 squared over 3 squared. So that means it's 1 over 3, naturally. Because that makes a lot of sense. Doesn't make so much sense. The product in simplest radical form. The square root of 1? What is the square root of 1? It's 1. Oh, so it's just square root of 5. Easy. That's the square root of 12 times the square root of 42. So that means it's the square root of... No. Square root of 2 times 6 times the square root of 6 times 7 or square root of 2 times 6 times the square root of 2 times 3 times 7. So 2 times the square root of 6. No. I could square everything. And then that gets rid of that. Oh, I'm so lost. I could do this. Hee hee. 6 to the 14. Okay, so... Oh. Okay, you can just rewrite it as a... Okay, so it's going to be the square root of 12 times 44, which is also the square root of 2 times 6 times 4 times 11, which is always also the square root of 2 times 6 times 2 times 2 times 11. So it's the square root of 2 squared times 6 times 2 times 11. Also means it's 2 times the square root of 6 times 2 times 11. So this also means it's the square root of 2. 6 times 2 times 11. Square root of 2 and then 132. This isn't going to be right. If I just divide that by 2, then it'd be just the square root of 66. Which is just the square root of 6 times 11. Which is also the square root of 2 times 3 times 11. Which is also the square root of... Okay, I'm just going to say the square root of 2 times square root of 3 times square root of 11. That's not going to be right. Is 4 times the square root of 33? That doesn't make any sense. Okay. Square root of 55 times 25. That means... Well, what's 55 times 25? So, okay, so square root of 1,375. X equals 12. False. No, it's true. Why is it true? 2x equals 24? Really? So the square root of 11. If you reduce it down as much as possible. No, it's not the same thing. Oh, it's 11 times 125. Which is also equal to square root of 11 times, okay, times 25 times 5. Why square root when you can times? It's just part of the problem. Square root, okay, now it's the square root of 11 times 5 squared times 5. So it's 5 times the square root of 11 times 5. So it's 5 times the square root of 55. There's no way that's the answer. That is all. Let's go. Thanks for the luck. Bye. 3 times square root of 7 minus 7 times the square root of 7. Is it negative 4 times the square root of 7? There's literally no way. That is so freaking stupid. I love it. 8 times the square root of 50 plus 10 times the square root of 2. 4 times the square root of 25 times 2. No. 8 times the square root of 50 plus 125 times the square root of 50. Oh no, 250. $258 times the square root of 50. Yeah, no, I didn't think so. 50 to the square root of 2. Is it 90 to the square root of 10? And in that case, 9 to the square root of 1? No. Okay. Nine to the square root of 50 plus 3 to the square root of 2.
In this video, we're going to focus on how to simplify radicals, including radicals with variables. We're going to also focus on how to add and subtract radicals, how to multiply radicals and divide them, including how to rationalize the denominator and when to multiply by the conjugate. So let's start with simplifying for cube root of 3. I don't know why I put 2. Maybe you can split it to the square root of x squared times the square root of x. The square root of x squared is just x times root x. Now, depending
times the square root of 117. 117. So 117 doesn't jump out at me as some type of a perfect square. So let's actually take its prime factorization and see if any of those prime factors show up more than once. So it's clearly it's an odd number. It's clearly not divisible by 2. To test whether it's divisible by 3, we can add up all of the digits, and we explain why this works in another place on Khan Academy. But if you add up all the digits, you get a 9. And 9 is divisible by 3, so 117 is going to be divisible by 3. Now let's do a little aside here to figure out what 117 divided by 3 actually is. So 3 doesn't go into 1. It does go into 11 3 times. 3 times 3 is 9. Subtract. You got a remainder of 2. Bring down a 7. 3 goes into 27 9 times. 9 times 3 is 27. Subtract and you're done. It goes in perfectly. And so we can factor 117 as 3 times 39. Now 39 we can factor as, that jumps out more at us, that's divisible by 3. That's equivalent to 3 times 13. And then all of these are now prime numbers. So we could say that this thing is the same as 5 times the square root of 3 times 3, 3 times 3, 3 times 3 times 13, times 13. And this is going to be the same thing as, and we know this from our exponent properties, as 5 times the square root of 3 times 3, 5 times the square root of 3 times 3, times the square root of 13. Now, what's the square root of 3 times 3? Well, that's the square root of 9. That's the square root of 3 squared. Any of those, well, that's just going to give you 3. So this is just going to simplify to 3. So this whole thing is 5 times 3 times the square root of 13. So this part right over here would give us 15 times the square root of... Let's get some practice simplifying radical expressions that involve 14x squared. Pause the video and see if you can simplify it, taking any perfect squares out, multiplying, and then taking any perfect squares out of the radical sign. Well, let's first just multiply this thing. So we can change the order of multiplication. This is going to be the same thing as 2 times 3 times the square root of 7x times the square root of 14x squared. And so this is going to be equal to 6 times, and then the product of two radicals, you could view that as the square root of the product. So 6 times the square root of, and I'll just leave it like this, 7 times x, and then let me actually factor 14. 14 is 2 times 7 times x squared. Actually, let me extend my radical sign a little bit. All right. And the reason why I didn't multiply it out, obviously we could have multiplied in our head, x times x squared is x to the third, and we could have said, all right, 7 times 14 is what, 98? We could have done that. But when you're trying to factor out perfect squares, it's actually easier if it's in this factored form here, especially because from a variable point of view, you could view this as a perfect square already. And then 14 is not a perfect square. 7 isn't a perfect square, but 7 times 7 is. 7 times 7 is a perfect square. That is 49, of course. So let's rewrite this a little bit to see what we can do. This is going to be 6 times, and I could write it like this, the square root of, and let's put all the perfect squares first. So 7 times 7, that is 4 times this. 14 times isn't a 5. Perfect right there. 36 and x to the factor. Because let me just I'll do more steps than you would probably do if you're doing it on your own, but that's because the whole point here is to learn.
Minus 5 times the square root of 18. Right now, we cannot combine them because 8 and 18 are not the same. But sometimes, we can simplify the radicals and make it the same. 8 is basically 4 times 2. 18 is 9 times 2. The square root of 4 is 2, and the square root of 9 is 3. 3 times 2 is 6. 5 times 3 is 15. Now notice that we have like terms. So now we can combine them. 6 minus 15 is negative 9.
Oh.
So the final answer is negative 9 root 2.
Okay. So you have to make them like terms. So 45 to the second plus 3 to the second, that would be 48 to the square root of 2. Oh, that makes so much more sense. Oh my goodness. Okay. Okay, so it'd just be negative 10x. No? Oh no, it'd just be 10x because of the negative exponent. No? Oh, what the frick? Okay. So negative 8 over 8 times negative a to the 6th over a negative a to the negative 2nd. So that's 1 times a to the 8th. So it's 1 over a to the 8th. Or it better be. Oh, you've got to be kidding me. Okay, so since there's a negative exponent, you just multiply them. It's negative 2 over 12 times b minus 2 negative 1 over the 6th b minus 2. What the heck?
Simplifying rational expressions is just like simplifying fractions. We want to simplify out all of the common factors between the numerator and denominator. And there are a couple ways of showing this. If we have a hard time identifying the common factors between the numerator and denominator, I think it's best to write everything out in prime factored form. So let's start by finding the prime factorization of 28. So we'll make a prime factorization tree. We can write 28 as 2 times 14, where 2 is prime, and 14 is equal to 2 times 7, both prime. Which means we can write 28x as 2 times 2 times 7 times a factor of x. Now we'll make a tree for 56. We can write 56 as 7 times 8, 7's prime. 8 is equal to 4 times 2, and 4 is equal to 2 times 2. So the prime factorization of 56x is going to be 2 times 2 times 2 times 7 times x. And now in this form, we can easily identify all the common factors between the numerator and denominator. 2 over 2 simplifies to 1, 2 over 2 simplifies to 1, 7 over 7 simplifies to 1, as well as x over x. Remember, all of these that we crossed off simplified to 1, so this simplifies to a 1 in the numerator and a 2 in the denominator, or 1/2. Of course, we can save a little bit of time if we recognize that 28 is the greatest common factor between 28 and 56, so we could have written this as over 1. That's 1/3 of x, 61.
I don't understand. I don't understand. Ah! Okay. Use the associative and commutative properties of multiplication to group the coefficients and variables. Okay. Negative exponents can become positive if they switch from the numerator to the denominator, or vice versa. Since both of them have negative exponents, switch the terms to make the exponents positive. Then simplify the individual terms and multiply them back together. Oh! Oh, that makes so much more sense. Okay. So it's going to be that, and then a second, a to the 7th, and then it's going to be a to the 5th over 1. I'm like this. I like this. I like this so much. I am so tilted right now. Okay. Okay, that's fine. Just make it so that I'm off by a single number. That's fine. I'm so glad when I'm never gonna have to deal with this ever again. I don't know how that makes sense. Oh, that's so annoying. How does that make sense? At all? In the entire frickin' world. Nice. Thanks for giving me the one easy problem. I hate this assignment with all of my being. There is no way I got that first try. I spent an hour and 30 minutes on that assignment. Am I tilted? Yes. Yes, I am. But I did it. I still have just a little bit of sanity left. You know what? I think I'm gonna end this stream here. Bye.